So we have all that in the notes from yesterday. Okay. So today we're going to be putting all these pieces together now to create that confidence interval. The last problem we did yesterday was just looking at a confidence interval and finding the mean of the sample and the error. So if you want to find your confidence interval, which remember we are always going to be estimating the population mean, to get the lower end of your interval, you're going to take your mean and subtract the margin of error. To get the upper end of your interval, you're going to take the mean and add your margin of error, which we already have those numbers from yesterday. So let's see what we get. On the top end, I get 21.76. On the bottom end, I get 20.34. So that's your confidence interval. And remember, you can see this written too. It'll kind of look like a point with parentheses and a comma between the values. All right, so that's our estimation of the mean of the population from this sample. Now it says to interpret the meaning. So remember yesterday we said there's two different ways you can say this. You can either say, because it's a 95% confidence interval, that we are 95% confident that the population mean will fall between these two values, or you can say there is a 95% probability that the population mean will fall between these two values. So however you want to word it here, I'm just going to say we are 95% confident, paraphrasing, that always what we're estimating is the population mean. So here that would be the mean of all student athletes and the number of hours they spend on their activities is between 20.34 and 21.76, and everything in this problem yesterday was hours. We would label it. So 95% confident, or there's 95% probability. All right. After you've got that written down, get your graphing calculator out, and I want you to put this data in L1 in your calculator. I'm going to show you how you can get a confidence interval with the calculator. Or you can check your confidence interval even, if you want to. So I'll get mine loaded up. Let me find it. There we go. So L1, there's 40 values you need to get in there. All right, so what we're going to do, we just found the 95% confidence interval. We're going to find a 99% confidence interval with our calculator, and then we're just going to compare the two real quick. So to do that, you're going to hit, it says it on here, stat, and then you're going to go over, we haven't used this one before, tests to the right. And then you're going to go down to number 7, which is a Z interval. When we're using our Z confidence intervals or Z critical values, we're using the Z interval. We'll do a T interval next week. All right, so Z interval, where it says input, should say data. Standard deviation, you guys need to put that in. This was given in that problem. It was 2.3, standard deviation of the population. Then list should be list 1. Frequency should be 1. I think that's already probably in there. And then your confidence level, we want a 0.99. We're going to find a 99% confidence level. Okay. And then hit calculate. And then at the very top, it's going to tell you what that confidence interval is. So here it's 20.11 to about almost 22. It also tells you the sample mean for what you put in, 21.05 that we found yesterday. And then it also tells you the standard deviation of the sample if you were to need that for something. Did everybody get that okay? Yeah. So how does this confidence interval compare to the 95% one that we found a minute ago? Wider, narrower? What do we think? It's wider. Yeah, you've got a smaller lower limit and you've got a bigger upper limit. So if we're trying to approximate the mean, the 99% one is going to be wider because the probability that our mean is contained in that is higher, right? So the wider we make it, the more likely it is that our population mean is going to be located there. But the downside to that is if you're truly trying to estimate the population mean, a wider interval means the estimate is maybe not necessarily as accurate, right? The smaller our confidence interval, the closer we're going to get to the mean. It's just less likely, less probability, not terribly bad, you know, if it's 85% or 90%. That our population's mean is contained there. So that's why intervals change for these, our confidence levels. We don't always want to use like 99.9%, which we could, but then you're going to get such a huge interval that your values might not necessarily mean a whole lot. Okay? Questions on that? All right, cool. So what we're going to do now, we're going to do this one together, practice putting it all together now. We're going to create the confidence interval for, in this one, an 85% confidence interval for the population mean of closing price of Apple stock. So we're going to try to pull the important information from this to start. We've got a random sample of 36 business days. So 36 business days is what in terms of all my variables that we're going to need for this? That's our N. It's our sample size. Then we have a mean closing price of that sample. That's our X bar is $116.16. Sometimes you'll be given it like this problem, or sometimes you'll have a set of data and you'll have to calculate yourself, like the last one. You also know the population standard deviation is $10.27. We want an 85% confidence interval, so that's your C is 0.85. And then once you have your confidence level, you should be able to find the critical value, your Z sub C that goes along with that. Remember that many of the ones that are used commonly are on this sheet here, on the negative side of your standard normal table. The downside is 85% listed there. It is not, but you can add it on in a second here if you want to on your paper. So let's say it's a confidence interval and you don't have it on here. Here's what we did yesterday. Remember the picture that had the normal curve and it was like shaded blue in the middle and it was yellow on either side? That's what we're going to do. So we're going to take our confidence interval, which is 85% of the data is located between these Z sub C values, and we're going to find the complement of it. So 1 minus 0.85 gives me 0.15. That's the area in this curve that's located in the tails on the far left and far right. If you divide that by 2.075, that's the value that you can search for in your table to find the critical value that you're looking for, the Z-score. So find in your table the Z-score that has an area to the left of 0.075, so it's going to be on the negative side. And we're going to find the value that's the closest to it that we can get. And it is, do you guys see negative 1.44 there? Okay, so remember when we get Z values, there could be positive or negative. We really have two critical values, one on the positive side, one on the negative side. So plus and minus 1.44 I can get from my chart. Then when we calculate the margin of error, we'll just use the positive value for that. So that formula from yesterday was the critical value times the standard deviation of the population divided by the square root of the sample size. So for our problem, it's 1.44 times 10.27 over the square root of 36. And if you guys want to on your chart, you can put that critical value for Z down with the other ones that are listed there for 0.85, so you have it if it comes up on any Math Excel problems. All right, type that in your calculator. And I get, I'm going to do 2 decimal places because everything here is stock price, 2.46 for the margin of error. Good. Okay, so now to find the confidence interval, we're going to take our X bar, which was 116.16, and we're going to add and subtract that margin of error. When I add it, that's going to be the upper end of my confidence interval. When I subtract it, it's going to be the lower end of my confidence interval. So 116.16 plus 2.46. On the top end, I'm going to get 118.62. 116.16 minus 2.46 gives me 113.7. I'm going to say 70 again because everything here is dollars and cents. So if I were going to interpret this, I would say that there is an 85% probability that the population mean, so the mean of all stock closing prices for Apple over that year, is between 113.7 and 118.62 dollars and cents, of course. Okay? Make sense? All right, you guys try the one on the back now. Find all your pieces and parts and then construct a 90% confidence interval for mean age in this problem. All right, did you get a margin of error of 0.55? Add and subtract that to the sample mean, you should get a confidence interval of 22.35 to 23.45, if I don't round anything there. And then summary of that, we can be 90% confident, or you can say there is a 90% probability that the mean age of all college students, so that population mean, is between 22.35 and 23.45 years. Okay? How'd you do on that one? Good? Any questions? No? Okay. Last problem's a quick one. And then we'll wrap it up. You guys can work on your Math Excel a little bit. It takes our error formula and we solve for n. So we've got this guy over here that we've been using. If I get n alone in that formula, I end up with this. So we use this if you have kind of a goal in mind. So let's say you want to be a certain level of confidence and you know what you want your margin of error to be. Maybe you're doing a certain sample and you need the margin of error to be like within 1 unit in either direction. This tells you what the minimum sample size needed is to ensure that you're going to get that margin of error. So this would be something that you would do before you perform an experiment or a survey to figure out how many people do I need to include or how many samples do I need to take to make sure that my margin of error is whatever I want it to be. But it's very easy. You just kind of find your values and plug them in. So it says here we're going to determine the minimum sample size. If you want to be 99% confident that your sample mean is within 2 units of the population mean, and then you've got a standard deviation of 1.4. All right, so what is my C value here? 0.99. Standard deviation we were given 1.4. If the Z or the C value is 0.99, my confidence level is 90%, what's that critical value that goes along with it? 2.575. You can find that on your paper. And then the other thing we need is the margin of error. What do you think the margin of error here is? Yeah, when it says within 2 units, that means we want to be plus or minus 2 units from the mean, which that's what a margin of error is. So plug it in. N equals my critical value, decimals there, 2.575 times the standard deviation, 1.4, divided by the margin of error, 2, and square it. I don't think that's right. Typed in the wrong number. 3.24. Okay, now remember this is sample size, so your answer is not going to be a decimal. If your number is not a whole number already, we're going to round up to the next whole number, whatever that is. So in this case, we would round up to 4, which says if we want this confidence level with this error, then we need a minimum sample size of 4. Again, we know that the population is normally distributed, so we don't have to worry about it being greater than 30, of course. Okay, and that is it for 6-1. Questions for me? Great. So the last almost 20 minutes are yours. Your 5-4 Math Excel is due tonight. So if you have not finished that Math Excel, that's probably going to be your priority right now. 6-1, this lesson is due on Tuesday night next week. Oh, no, I take that back. Might be due on Monday. 6-1 is due on Monday night, but you have a Math Excel work day on Monday. All period long, you're just going to be able to work on your 6-1 Math Excel. Okay? So go ahead and get started on that. I'll do the cell phone lotto. And that's it.